3 parts on one machine. All 3 parts must be produced, have a long-term demand. So we have this table. So this is the number part, this is the annual demand, this is the setup cost, this is the unit cost, and this is the annual production rate. Just as I see, the demand and the production rate should be switched. So this is the production rate. So production rate. Let me just fix it. Anyway, so this is the production rate, and this is the annual demand. So okay, so this is the demand, and now we want to know, we have this question. So the inventory holding cost is based on an annual interest rate of 0.18%. The parts must be produced in a cyclical rotation order. Assume that setup time is negligible. Requirement: what is the optimal cycle time? So as in the last video, it's really easy. We just sum all the demand divided by the production rate, and we get a 0.2488, meaning we can actually produce it. And now, in order to find the cycle time, we'll look at this formula, which this formula will help us find the cycle time. So this is the holding cost when there is no production, and this is the fixed holding cost when there is production. This is the formula I'm using. I just plug in the numbers, and I'm getting each holding cost, and then I'm plugging into this formula and getting the cycle time. So it's 0.1373 years, or every like 7 weeks. And now for the second question: what is the optimal production quality for each part in each rotation cycle in the optimal solution? So we ask about the production quantity for each part in each production rotation. So it's really easy. You look at the demand for a year, multiply by the cycle time, so by 0.13723, and then you just get the numbers. And for C, what is the average annual total cost of setup and inventory holding for the part in the optimal solution? So what is the average annual total cost? So it's really easy. We have this formula to calculate it. And I just plug the numbers into the formula. I get 3,007,087, and that's it. And the last section is what percentage of the time is the machine idle, not used, or production. So this is a really easy one. So we look at the first section for the sum of DJ divided by PJ. So if we look about this in a year you will use the machine, the sum of this demand. So around 0.2488, minus that, meaning all the time the machine is not used, will be like around 75%. So 75% of the time the machine is not doing nothing. Guys, hope you liked this video. Please like and subscribe. Subscription is the most important thing. Until next time, I'm out.